Hello, everyone. Welcome to the Practical AI Predicting Business Outcomes with Analytics panel discussion. It is a great pleasure to be here. My name is Tomasz Molarczyk. I'm working at Spirosoft, a Polish software development agency, and we work across different industries like automotive, geospatial, healthcare services, financial services. And we have the AI unit that is working across those different industries, working on classification, regression, text analytics use cases. And together we have wonderful panelists together with me. We have Puravi Bhattacharya, senior data scientist and analytics, BI and performance reporting at Energia, a group, Energia Group, an Irish energy company. And we also have Matt Schubert, director of data science and modeling at Experian, based in the US. I hope we will also have soon Nirupam Srivastava, vice president of strategy and AI at Hero Enterprise, based in India. And maybe let's start with a round of introduction. Can you tell us a bit about yourself?
Hi, Matt. Hi, Thomas. Thank you very much. So I'm Puravi Bhattacharya. I'm a senior data scientist at Energia. I lead a team of data science, analytics, and BI. I have 10 years of experience in machine learning analytics across banking, finance, and energy sector. Thank you.
And Matt, how about yourself?
Hi, I'm Matt Schubert. I lead the commercial data sciences efforts within Experian's Business Information Services business unit. I lead a team that includes data scientists, data engineers, and predictive modelers. Personally, I have 15 plus years experience leading data science and machine learning efforts within several large global financial institutions, including working for Experian as more of a fintech and some other technology companies as well in the past.
Mm-hmm. So let's wrap up with the first and start with the first question, maybe to you, Matt. Do you see any differences between the type of clients or the type of industry or problems that you see, and the way how you support different clients, given also your vast experience in different industries? Does the approach to the analytics differs somehow?
Yeah, I think it really comes down to the analytic maturity of your audience or your client that you're working with. And that's where we take a very consultative approach to really understand not just the data they have to work with or the data we can help them to improve their process, but also the true understanding of the business process itself and how there's a relationship to, sometimes it's not just a modernization of a more artificial intelligence or machine learning based approach. Sometimes it's also a modernization of the overall business process and changing the key drivers. To become a data-driven organization, there's really a difference in the curve of analytic maturity. And we truly try to help and identify where they're at first before we start to try and make any recommendations or proposals on ways we might be able to help or things they may be able to do with our data. A lot of it comes down to they may lack some of the basics, like a level of data quality that's needed to produce clear, consistent, proven insights. And that's where some of those consultative efforts help identify some of those gaps early and either how to remediate or improve or find ways to maybe augment that and use a different data source instead of some of their own internal data. Obviously, there's modeling techniques and things that can be done over time, imputation and corrections, but it's really, if you don't clean up the signals that you're trying to predict and the predictive events you're trying to determine, it's really difficult to have consistency. Even if you look at applications of something like iRobot with a vacuum that goes around the floor and picks up all the dirt and stuff automatically, it has to learn and have that predictive process. Well, the same thing applies to all types of industries. And that's where we see with our clients is really trying to be consultative and understand how do we make sure we keep getting a consistent feedback loop and also a consistent predictive loop to be able to create the products or services that we're able to provide.
Mm-hmm. And given the analytics maturity concept that you have touched on, there are probably different stages how the company can work with analytics, going from the, let's say, more of a diagnostic or descriptive analytics, telling you how the past have looked like, what kind of sales you have last year, going just to the predictive and prescriptive analytics, which is more probably the field of the AI. Do you believe that a company that right now is struggling, let's say, with the diagnostic phase or the descriptive phase can jump into the predictive and AI field, skipping the lower parts of this analytics maturity, or should it be somehow graded and done in steps?
Yeah, I think it really depends on the organization. A lot, like I mentioned before, is data quality is a big hindrance at times, and I think that's where some of the descriptive and diagnostic components can help maybe address some of that and get some of those things fixed. But I would encourage clients to try to harness what they have today and find ways to make some of that movement. It's really difficult to jump to prescriptive without at least doing some level of predictive. It may not have to be a predictive model. It could be just a signal that's created that is, whether it's through a supervised or unsupervised approach, and to use that to start changing some of your business processes around some of that whether it's a targeted type signal or a non-targeted type signal, change some of the approaches that are taken. And I think that maturity curve, as mentioned, where you go from descriptive or diagnostic to predictive to prescriptive, it's difficult to skip, but it's not impossible. I think the steps that you have to take is really identifying, do you have the data to work with to be able to get to prescriptive? And then have you really considered your business process? Has it been shifted to the point where it can actually ingest data as a key driver? That's the hard part, because that's the problem with a lot of analytics. They end up staying on the bench or the shelf because they haven't been considered how you're going to integrate easily into a business process. And I think that's where the prescriptive piece comes in, whether it's or a recommendation engine or something that's replacing that human everyday interaction that may be happening. Could be call center management. There's all kinds of use cases out there to be applied to, and I think it really comes down to the organization. Some of the folks we work with, I've seen very high quality descriptive and diagnostic type of analysis and reporting and analytics, struggling to even get just to predictive, to be able to build models and make those predictions on their everyday business. And sometimes it's because they don't have an easy way of identifying some of the targets they need to work with, or they've been trying to identify the wrong target. And it's almost like the measure twice, aim once kind of thing versus, or shoot twice, aim once kind of thing, versus you probably should aim twice and shoot once type of thing. That's where we see the biggest gap, is just that understanding. And I think clients would, at least the ones we work with on a most basis, a lot of them have refined their internal reporting and descriptive analytics over the years. So I'd say most of them are higher on the maturity curve, but then we have some folks that are very small and just getting started in the last few years, and they're much further behind, and they need to have had all that enablement to help catch them up a little bit.
Mm-hmm. And maybe, Puravi, do you think that this kind of analytics maturity could be sector specific, especially given your experience right now with the energy sector, how AI is transforming the energy sector, and how they are prepared to work with the analytics and artificial intelligence?
Yeah, sure. Well, yes, as well Matt mentioned, different companies, different sectors are on different scale of the analytics maturity. It's very key for identifying each company before they even, think about bringing AI into their process, is to understand where they stand in terms of the analytics maturity. And yes, different sectors have, have covered their journey. Like banking sector, they have a warehouse and, BI intelligence systems in 1940s, and where they are striking is like to, how to innovate. Like they are sitting on this massive amount of data, and it's to find out, monetizing this data and to really bring some key insights out of this data. But then in energy sector, there's different challenges that we have faced. I really like to cite a few examples. So the power plants and the energy transmission plants, these have been like 30 to 40 years old across Europe and US market. And there has been no technological upgradation in this transmission entire network system since it was actually established in 1882 by Thomas Edison. So AI is kind of in early stages in this entire sector, but then definitely it has a lot of scope to actually revolutionize the way we produce, transmit and consume energy. On demand side, it's really about actually modernizing the entire grid. We call it a smart grid, and AI will be at the heart of this entire smart grid, where it will be actually forecasting the weather prediction, forecasting the anomalies that could happen in power plant, and then based on consumer nodes and then these transmission networks, it can actually predict how much of it will directly impact your demand and then the pricing in the price markets. And at the same time, on supply side, on consumer side, the smart meters are the newest thing. And these are kind of mandates in Europe, Australia, and already installed in UK market. It's quite new, already in implementation phase within Ireland market. In 2020, it will be launched. So the smart meter will enable consumers to know how much they are consuming in off time and their non-peak hours. And this entire system, once it is installed, the AI and machine learning algorithms can actually help in predicting when could be is a high peak time, when is a non-peak time, and thus enabling entire system to efficiently use fossil fuel and then back it up with the renewals and the other other green energy supplies like wind, solar, or other such biofuels. And this will actually revolutionize in the fact that we will not just be efficiently consuming energy, but also be more eco-friendly, supporting climate change. And this, how I see it, there's definitely a very massive impact in future.
That's a very interesting perspective on the energy sector. So maybe Matt, do you have any other impactful use cases from the AI field? Where do you see value in artificial intelligence?
Yeah, I think it's really interesting. So you mentioned the smart grid, and that's a great application that is going to be quite the differentiator, and it's a great example of some of the I hate to call it the replacement of people, but I think it's the efficiency and the augmentation of the everyday work that happens, and that's where I see a lot of shifts happening. One thing we do internal with some of our own efforts, so there's a lot of document review that has to happen within Experian, and they've been creating using robotic process automation, using bots basically on a program on a computer to replace a lot of the efforts that would be a manual review. And we've seen some improvements where someone could go from reviewing maybe 10 to 15 documents per day to now they're able to review the results from the RPA process, process automation, and review maybe 100 to 150. So it's basically a 10 times increase in productivity that ends up getting achieved. And that's just a simple example where, and it doesn't mean that it's obviously people worry the robots are going to replace the humans and the workforce is going to be taken over and all those kind of things, but it's really more of an efficiency gain. And that person's time can be spent more on looking at the details and the differences and the gaps and really looking at those maybe 2 or 3 out of the 100 to 150 that have a major issue that need to be researched much more heavily. But it would have taken them weeks to get to that same 2 or 3 issues versus with the AI process being built in. So that's just an example I've seen internally that we've been applying. I also have seen a lot of clients trying to add like chatbots to a lot of their interactions. If you go on a financial services website, a lot of times there's going to be a chatbot that says, "Hey, how can I help you?" Personally, I think sometimes those can get a little bit intrusive and a little bit aggressive, but it makes it a layer where instead of just having that automated dial-up system, you're also going to have that through a digital interaction. You're going to have the same type of automated process or more of and sometimes they're just referencing a search of some kind that's going to try to find a frequently asked question, but sometimes they're a little bit more, there's a level of AI there that is able to go a little bit deeper. And so I think that augmentation and efficiency gain, that opens up call centers. If a chatbot can take care of first level, second level type questions, that opens up that call center to deal with the issues where maybe it's fraud or something else that has to have a deeper dive that a chatbot's not going to be able to resolve. But it opens up the capability or the ability for those folks to dive into all those areas. So I think that augmentation of the workforce is going to be one of the big transformations that you see that AI is able to drive a lot of those efforts.
That's very interesting, but it also showcases how broadly the AI could be implemented and how many use cases we can find for it. We have very interesting question from the audience asking about any general advice how businesses with no AI or machine learning experience can start, where they can look for some kind of advice. Ravi, do you have any takes on that, given also your recent experience?
Well, yes, definitely. As Matt clearly mentioned, yeah, it is it is not advisable to directly jump into a higher level of machine learning algorithm, but even to start with something very basic to understand, like descriptive, understand your business by analyzing the data that you have gathered, whether it's a customer operational data, whether it's a customer demographic data, or whether it's your simple business process data. Try to understand what's happening, understand how data is it's first of all how that data is gathered, understand different data points, understand how this data can give you initial indications how your business is performing, and then there are certain hidden clues that you can actually take back quickly and have some quick win backs. And from slowly moving from initial descriptive to a kind of diagnostic, if you have find out that certain areas are more problematic, then you can look around some proof of concept case studies or some initial project just to understand if there is really some valuable, because every time I've noticed that a lot of projects actually begin with a lot of enthusiasm, but then the time that it takes to from proof of concept to actual production is so long that, and the commercial value which we gain out of it is not that great. It's essentially, is always in business a question, or it's a balance that we need to maintain between overall cost and actual efficiency of it. So as a new business, one need to understand that how much of time and effort can be given into certain project, and how much of utility or how much of actual impact can be gained in business from that. That could be a beginner's place, I guess.
Mm-hmm. So like the proper business case and the calculation of the possible impact of the given use case. Mm-hmm.
Yes.
We encourage all of the participants to ask questions in our channel. We will try to answer as many of them as possible given the time that we have. And moving forward, I think this is very close to starting from zero, because we have or we see a lot of startups developing AI technology and collaborating with corporations, but they very often struggle with the proof of concept phase and how to take that into the production phase. My colleague also had a discussion with one of the senior directors in one of the corporations, and he said that they have more pilots than Lufthansa right now with AI. And the question is, what kind of practical advice, maybe Matt, would you have in terms of how we can escape this kind of pilot trap that we can see with AI projects?
I think there's two elements I would recommend to avoid the pilot trap, and I think that's I mentioned earlier, it never gets off the shelf. Something gets discovered, it gets built. Somebody starts on their desktop, they build something really cool, and then come to realize, hey, there's no data pipes available to be able to do anything with it downstream. But that's an example that I run into personally over the years, and I think one of the first easiest way to avoid that is really understand the business value that you're creating. It's much easier to get sponsorship to pay for all that technical infrastructure that might be needed when you can say this is going to create $10 million. If you build something and you say, I'm not really sure what the value is going to be, you might have something that could create a ton of value, but you haven't really identified the business process to understand, is it going to be a revenue generation? Is it going to be a cost efficiency gain? Is it going to be a combination of both? What are the real business value adds? Much easier to get a project moving along, much easier to get, even if you're a startup trying to get a buy-in. If you can prove that business value to your client, they're going to be much more prone to spend the money and invest and make that opportunity get to fruition. So that's number one. Number two, in my role, I've experienced this experience. We have to, somebody has to be thinking about the end game in the process. That's one thing with data science is it's great to go out and explore and run hypotheses and experiments and see what you can create and what type of cool insights you might be able to find or predictive outcomes. Someone has to be thinking about that end game. Where's deployment going to be? How's it going to be achieved? How are you going to get this to production? Because you can do something pretty cool on your desktop doesn't mean you're going to be able to put it on a server or cloud or somewhere else to be able to run efficiently. And that's that part where that's a lot of what my role ends up being at times, is identify how do we get to that end game? What's the technology infrastructure we're going to need to be able to put this into production? How are we going to have to adapt our business process so when it does go in, it actually changes the outcomes that were occurring before to be able to measure and monitor against. So that's where I think the two areas is really understand the business value, understand where you're going to get to. That other part of where you're going to get to is difficult sometimes, especially if you don't know exactly what your client's infrastructure is at the time and some of those areas. But if you can prove them there's a value, I think it makes it easier to get to jump on board and go along for the ride.
And again, interesting question from the audience. Where, given the GDPR that we have right now and all of the requirements, we can create with AI different types of system, like rule-based systems or neural nets that are much harder to explain, but usually achieve much better results. What are your perspectives currently on what kind of use cases are good for the models that we can explain, and what kind of use cases are good for pure, I would say, performance models like neural networks that we do not have an easy way of explaining the prediction?
Yeah, thank you, Thomas. First of all, the question is very interesting and very relevant to a newcomer who is like new and exploring this business or the space of data science. So this question, instead of whether, so whether it's a rule-based or it's a neural network, everything has to comply GDPR. It's business mandate. There's no exception to that. So that's the first answer. And whether one should go for a rule-based or a neural network, that actually depends on the business case. So it's very important, it's not that, I have seen that some of my new junior, data scientists, when they join, they're so excited. They start actually, fitting every possible model they have heard of, they have learned in their, universities and academics, and they just come back. And then that's not the way it is. It is essentially, we have to understand the objective. So whether it's a classification problem or whether it's a segmentation problem or it's actually you're trying to predict something. So that will actually, drive which kind of modeling technique that you want to use. So at times from the business objective, it is very important to understand what are the drivers. I'll take a very simple use case, say, for example, churn prediction, which is a very, famous practice case study that is quite often used in most of the academics. And so when it's a churn prediction, one can definitely go for neural network. But then when it's to understand that what are the drivers of churn, then a rule-based algorithm is much more helpful. So it essentially depends on what is the end objective or the goal of that study. And again, it's very important to understand the neural networks are kind of bit hungry algorithms. They really need a huge amount of data set. And you already, if you're facing a lot of data problem that you do not have access to large data set, neural network might not able to give a very good result in the validation, like the final real world data. It might really fare well in terms of your test and your training a test data set, but might not fare equally well when it comes to real world validation, unseen data. So it's really important to understand what's the objective and then decide what best algorithm to begin with. Matt, if you'd like to add something more on this.
Yeah, I think you made some great points, and I just one thing to add. They mentioned GDPR specifically. I've actually touched that a little bit in my career, and I can tell you there's neural networks are going to be very difficult to completely meet that regulation. Mainly just that the hidden node, hidden layers. I know there is some work around trying to break some of that open and identify that, but I wouldn't let the lack of. It really depends on. I think you mentioned the best method for the best approach or the best application. And I think you're exactly right when you mentioned that you got to make sure that the right one's being chosen. In my experience, we've had more success with gradient boosted trees and random forests with the data that we work with than we have with neural networks. There are neural networks sometimes will get close or maybe even slightly exceed, but it's never enough lift to say, hey, that's the method we should really go fight to try and get through the process. And so I think you have to look at your data, and I think you're right. If you have a lot of neural networks really live off of having a really large blood flow of data flowing through to get some of that gain and that lift. And I think you'll see probably more applications maybe in like image and natural language processing in some of those areas where neural networks might make a big difference. But in a standard classification problem, you might not get the lift that you would expect. Now, without doing a lot of your data preparation and your transformations and your feature generation, you may see that achievement from a neural network because it may be doing some of those things on its own. But if you do the right data preparation, feature generation with your data, you're probably going to get the same lift. Segmentation, we see great value in even doing segmented models on some of the gradient boosted tree approaches we take. Overall, a point or two of lift isn't huge, but when you start looking at repetitive millions of transactions, that point or two lift can make a big difference in the end.
Yeah.
And also, we're trying to explain that a neural network sometimes is much more computationally intensive than just calculating the network itself.
Yeah, that's that deployment. I didn't think about that. You're right. The deployment pieces, it's so labor intensive to be able to create each one of those, and sometimes that cost of per record is going to be just not going to make sense in the end. So.
Yeah. Okay, so given also this trend of explainability, we also have seen trends around the responsible AI, avoiding bias. How can we ensure that the organization AI strategy will lead to responsible AI? What kind of practical steps can we make to make sure that we do not instill any kind of biases or discrimination into our algorithms? Do you have maybe any advice for clients with regulatory related use cases, Matt?
Yeah, I think it really comes down to really identifying the data that you're putting into your process. If you can find some level of interpretation of the data that you're putting into your process, it's going to make that process a lot more transparent throughout the rest of the layers that are involved. Now, it's also depend on the method you're using. Some methods are going to be more explainable than others. We experience a lot of our experiences. We see tree-based methods being a little bit more interpretable. Obviously, gradient descent is its own process that has to be explained and described to really get into the details. But there's still a foundation based off of tree-based methods that exists there. There's no black boxes. There's no hidden layers. We find those to be more acceptable in regulatory-related use cases. If discrimination is a big concern, I think it's important to make sure you are using those more explainable, accepted type of methods. If you're, for example, if you're programming an iRobot vacuum, you probably don't have to worry about discrimination. I guess we could worry about it chasing people around the house based off of certain demographics and things, but I think that's less of a concern in that situation versus you probably don't want a self-driving car to discriminate. You probably don't want your decision on a loan to be discriminated upon. There's certain layers where you have to understand what that end use case is, and do you really need to have that layer of explainability and to reduce the bias? I do see the concern in a lot of use cases, especially if regulations involved. I mean, financial services, insurance, healthcare, all those areas are going to have a much more concern around bias and discrimination. So I think, like I say, input data is probably the first step. Understand the data that you're using to input, understand what the biases are within that data. And then if you do have biased data, make sure you're removing the process. Also, if you're doing a classification type of problem, make sure you have the right target involved. Make sure you're actually applying the correct target to your process to allow or to make sure you're not instilling your own bias and maybe what you're trying to predict as well. And then I think the other part is trying to break that, even the most advanced machine learning type-based methods into components that can be digestible and understood. Something we've done to meet the fair lending regulations in the US is we take an approach where we've basically replicated what was done for logistic regressions to create the adverse action reasons. And we've applied that to gradient boosted tree base using XGB, for example, process. Now, the difference is it's much more labor intensive. That loop is going to have to run, if you have 100 variables in your model, it's going to have to run 101 times to be able to do that same process as done with a logistic regression. But that's one way we've been able to achieve regulatory compliance. So, and it also gives a great explanation of what are the biggest factors that are impacting that score. And I think that approach could cross over to multiple industries and types. I mean, healthcare is going to need the same type of explanation if you're using AI or ML in some way to make patient predictions and patient determinations and things like that. So I'm sure there's opportunity in the energy space. I'm sure there's with a grid, you have to have checks and balances in place, and that's where some of that process can be applied to be able to determine what some of those checks and balances should be and whether something's acting or behaving as expected throughout the data ingestion process.
Mm-hmm. You have touched a very interesting point about understanding the data, understanding the target. There's a very interesting article from the Boston Consulting Group, and they say that the success of the AI implementation is only 10% about the algorithms, 20% about the technology that you use and the data that you use, and 70% about the business processes, transformation, business understanding. Puravi, what is your take on that? Is it something that you also observe in your projects as well?
Yes, absolutely. So it's very important, for any AI project or any AI strategy, to align with the business strategy. And to do so, it is very important for leadership, is to move from a leadership driven, a gut based decision system to a data science backed, a data driven decision system. And to really adopt into that, it's really important to rewire the entire organization's framework from a rigid, inflexible to a more adaptable, agile, and more flexible organization's culture. And this will actually enable most of the organization which currently work in silos, like all departments generate their own data, and they more often have some kind of inhibitions to share their data across, maybe due to technological barriers, or it could be due to just cultural barriers. They do not want to share their internal information, and that kind of leads to creation of those silos. It's really important for those organizations to understand that, and then start creating some kind of forums where interdisciplinary departmental brainstorming sessions can happen. So essentially, it's very important, and this will all come only when management themselves are ready to open to this idea, and they are the change drivers. They understand this. And so when in my own experience, I have noticed that any kind of AI or innovation change is very important, that it has to be top down, and it has to be equally managed by a change strategy. And communication is definitely key, but at the same time, it is important that a culture of open culture is developed, where people are actually encouraged to talk and open and express their ideas, even if it's fear of the change. They should be able to express it, and that should actually be taken care, addressed in a rightful manner.
Yeah, I totally agree with you. That's if you don't, the issue, if you don't open, that make it open and collaborative amongst all the folks, you may have a someone who becomes a hindrance in your process and actually affects some of what you tried to implement as well. That's where I see a big. I've seen that with clients where they end up having an underwriter who hasn't fully adapted to working with the recommendations, the machines that are being provided, and it has a direct impact on what their results end up being, because you end up having these a lot more false positive, false negative type situations because they're not actually following what's being recommended in the process. And that's where it's not that it makes what you've built any worse from a data science or predictive analytics standpoint. It just makes it more difficult to monitor and measure and know that you're not having bias thrown in other places that you were able to capture, or able to remove the bias from your process, but someone else is putting their own bias into it to affect it.
Yep, absolutely, Matt. Yeah, in my own experience, like we have developed certain of the brilliant models to support some of the managers for their day-to-day tasks, and it really actually, it makes the entire process efficient, less manual, error-free. But then they're so, used to their old system. It's easier to fall back to your old habits. So any kind of, not just AI, in terms of any technology project, has to be, introduced in a phase-wise manner, and the change that it brings has to be properly manage and really encourage across the organization.
Mm-hmm. Maybe another question from the audience, very interesting one, and I guess a very practical one. How competitive are the analytics products provided by cloud services like Amazon Web Services, Azure, Google Cloud Platform in the production? Do you have any experience with any also auto machine learning features of those cloud providers?
I do actually. I would say 5 years ago, all the cloud providers, I wouldn't say were competitive. Over the last couple of years, they've become very competitive. I'd say from an auto ML perspective, we've actually tested a lot of those out, provided by AWS and Azure, and I haven't come across one where I say it could replace what my team's doing yet.
Mm-hmm.
It may get there. I mean, what a data scientist does may be replaced by an auto ML or an auto process of some kind at some point. I still think there's a lot of value in the feature generation and taking the business, the knowledge of the business or the domain, and applying that to some of the features that are being created. And that's one thing that some of those auto ML or auto feature generation processes may miss. They may not understand that there is a relationship between two interactions that isn't easy to identify just off of predictive measures. And so that's one area I see. I think there's also I don't see none of them do a great job at what I call business driven or business rule driven segmentation. That's where I see a lot of lift and value in what we provide. So from an auto ML perspective, I think we're still probably a few years away from being able to say, hey, this can fully replace what the data scientist does. Now, maybe in 5 years, 10 years, that keeps evolving. I'm surprised at the improvements we've seen there over the last like 2 to 3 years. I will say we do a lot of work with AWS. We're actually moving to more of our processes. A lot of that where it helps is more the deployment side. Most of our models are deployed on an internal cloud. So that's actually where we get our efficiency gain to be able to run that I mentioned 101 times. That's actually how we're doing it. So we've built out a parallel process with distributed processing, 500 worker nodes. It can run 500 of those scores at one time in a loop to be able to produce the outputs. And so we see great value there in those services that are provided. The analytic products, I think, will probably likely keep improving, and they've had some great gains the last few years. I'm not sure, Ruby, if you've had any other experience as well.
Ravi, do you have any takes on the analytics products provided by the major clouds companies like Google, Amazon?
Yes. So as it's always this automated cloud services. They're definitely helpful, but it's equally important that the understanding of data that should always relies with the data scientist. So a data scientist will not be entirely removed. Maybe their role evaluate with changing times. And yes, a few years earlier, they did not have that much of capability. Now they have really gone, and in future, the future is always exciting and it's always something new, breakthrough, definitely. But yeah, the key is that a role of a data scientist will evaluate along with all these supportive technologies. So earlier, a data scientist was just simply, to understand data and put something on modeling. But nowadays, I've seen a data scientist also need to put on certain caps or certain hats at different times, like sometimes project management, sometimes, data strategy or data wrangling or data engineering, though they are not the direct roles. So yeah, and that's the idea. Like, it's a very continuously evolving area, and people really need to keep updated to the latest products and the requirements that comes alongside.
And touching also the same topic about cloud providers, what kind of tools for data science and business analytics would you recommend to start with? Maybe Matt.
Yeah, I'll be honest. My team uses almost, I wouldn't say everything out there, but we've tested almost everything out there. I'd say primarily it's Python, R. We do a little bit of things in SAS still. I would say the migration to that, we've looked at TensorFlow and Kubernetes and some of these other applications as well. I think it depends on the best tool for the best job. Most of our efforts we can isolate in Python for the most part. I would say there is some interesting streaming applications to use some of those other methods like TensorFlow that we've been evaluating as well. We don't have, our data doesn't have a lot of streaming type of component at this time, but it will likely in the near future with all the different mobile data that's available and different sources of real-time data that can be brought through different pipelines. So I think it just depends. Pick the best tool for the best job. A lot of it comes down to the coding background of who the data scientist is as well, where their expertise is. I've seen some folks build some pretty cool prototypes and POCs out of point-and-click GUIs as well, without having to write a single line of code. There's obviously a layer there that has to be determined with deployment to make sure you get that in a functional set of code to deploy. But I think it really comes down to what the skill set is and the knowledge base, and then what's the best. I mean, if you look at a set of hammers at a hardware store, you're going to have probably 5, 6 different types of hammers to pick from. Pick the hammer for the right nail, and that's kind of how I look at it. As mentioned before about the right data, you understand your data, you understand what works and what you're going to need for that specific job. So, I think the cloud services that they have with some of these auto ML approaches will probably become much more prevalent in the near future. They likely have some level of prevalence right now that I just may not be aware. I think it's a gap there, though. It's difficult to throw a bunch of data into an auto-based process and not have the same level of explainability and understanding on the output. So that's where it kind of comes down to a use case. Do you have a use case that requires you to have explainable data, explainable bias, explainable outputs in the end? If you don't have that, then that's probably not one of the best. If you don't have, that's probably a good approach. If you need those, you probably should avoid some of those processes because those processes don't have that. They call them auto ML. They don't call them auto explainability yet. I do know there's some things around explainability, but a lot of those are samples. So say on 1 million records you run through a process, maybe it samples 500. I don't think it's going to meet regulatory requirements in a lot of different parts of the world because you're really looking at such a small little isolated population versus what the overall population was.
Mm-hmm. Yeah. And given that there could be different tools for different types of problems, it can, I imagine, also increase the complexity of managing, let's say, a team of data scientists or business analysts. How can we tackle this complexity if, for example, we have a team of data scientists working in R, another team working in Python? How can we bring that together and make it more efficient?
I can handle one thing. Yeah, one thing we've been doing with deployment is we partner with our technology team for. They actually will. They prefer getting a set of Python code. So we either will give them Python code or we'll give them the other language, and then they'll actually convert it over to Python if they need to. I don't know if that's the most efficient way of doing it. I think there's other efficient ways. There's single deployment infrastructures you can use where you build in a constant set of language. I think it just depends on the process from a deployment and a technology standpoint. I think there's a little bit of I would say a best practice there would be try to pick one that you think is going to work in your production system and try to keep the code from having to change hands and testing and auditing. Those things you can test and audit all you want. I can tell personal experience from last year. We audited a set of code 3 different times and it still had problems when it eventually ended up going to the first customer. Mm-hmm. So it's one of those and it's because there's so many hands touching it. The easier you can go from development to deployment without having that code base change is probably a best practice to take. I think that's and then there's vendors out there that can support that and provide a single base platform. I think it can be built just off open source tools too. I don't think you have to buy a vendor solution for that. I think you can build in-house. We've done a lot of that ourselves. That's part of our transition from other languages to Python. We know we can deploy Python. They're going to be able to put a JSON wrapper around it, bring the data in for data pipes, and then they can have the Python still as the code base, and there's never a change. The testing we're doing is basically saying, hey, did they transfer the package right? Did they get the pickle file, the correct pickle file? All those kind of things that we're almost checking boxes versus saying, hey, we have to audit line by line to make sure they didn't do something that we didn't want to have done. So,
And for Ravi, what's your take on the complexity?
Yes, so I'd like to answer this in a very different manner than Matt. While Matt explained it in terms of organization perspective, if I see and look at this question from a student perspective, then most of the students, they come mostly equipped with R. They're very handy, and if they have some software background, they're very quick with learning Python. Now, R is definitely very good when it comes to statistical packages because they really have a huge library to support any kind of analysis, which sometimes it's difficult in Python. But then Python is the kind of industry-ready technology. It can be easily, plug in with most of the technology stack that is available out there. For my case, I've been moving into organization to organization, and there's always a different application out there. I have with most of the bank, it's SaaS-based platform, but then with current, it's mostly Adobe platform, a total entire different CRM that I've never worked with. Then there's ClickView. So I guess it's better to have the understanding of the basic framework, because whether it's R or Python, when it's looping, they actually create loops. So understand the framework well, and then whether it's R or Python, you can easily pick up either tool, whether it's you are implementing that in production in Azure or in AWS or in ClickView, whether you're doing business analytics in ClickView or Tableau, they all are written in a manner that anyone can pick up quickly if you really understand the frameworks well. So don't worry, it's really easy. They are actually made for making, they're made in a way that people can grasp things quickly. So there's nothing to fear that what is best tool. My suggestion is to understand the theory and the framework well. Choose, as Matt suggested, choose one language, be strong in that. I suggest Python because that is really easily integratable to most of the technologies out there. But then I understand if you're more statistically inclined, it is academically more preferred. But then if you really want to grasp quickly into business world, then Python is definitely ready to go to.
Thanks. You've touched also interesting topic about packages, for example, in Python or R. There are a lot of open source packages that are developed by the community, by the users. How can we use them and deploy them in production? Do you have any special processes to test those packages before you go into the production, or you just take them for granted and test them directly on the production? Matt, what's your take?
Yeah, we actually do extensive testing before we use them for anything that may go to production, just to make sure we understand the inner workings and that it's replicable results and that we think we're getting something that's trusted. A lot of packages Python we've seen, we're usually a version or two behind, and that's on purpose. That's with intention to make sure we have had that chance to make sure they're tested and I wouldn't say we have a process that they basically say, hey, these are the ones that are supported by technology. So that makes it easy. If it's supported by our technology team, we know it's been through some level of testing. And then we'll do a minimum amount of statistical testing as well to make sure we're getting the proper results and outputs. So I think it's great being on the cutting edge. The changes that are getting made to a lot of those packages on some of the version changes, a lot of it isn't anything that's going to be a big differentiator, at least from my experience, on something that's cutting edge. XGB has grown and adapted, and a lot of the gains now are making it more efficient. So I think it depends on a local run basis. Efficiency matters. On an enterprise level, efficiency is going to matter on a lot of records, but in your development process, it may not make that big of a difference. Having something run a hundredth of a millisecond faster, 200ths of a millisecond faster isn't going to change your overall results that much, or the output to results, or the time to results. So I think that's I would recommend definitely stick with the version control. I will say this: make sure you're something like best practice for folks. And I had this happen the last couple of years as well, where we developed in one version, and then when we went to deploy, we realized they had upgraded the version without informing us, and then we had to go back and retool because there was a misalignment with, I think it was an issue with the pickle files, didn't set up properly, and had to be we basically had to redevelop to deploy. So I recommend making sure you know where you're going to deploy, know what the versions are going to be, make sure you have alignment there. And if they have a change schedule, make sure you get a copy of that change schedule, because that's something we didn't get. And we learned late in the process that ended up delaying us about another month and a half to get to production. So with 6 weeks isn't too bad, but that's just something to know. That's 6 weeks where we weren't able to achieve business results from it. So that's part of the trade-off. So it's great having that open channel and know where you're going and how you're going to get there. So.
And perspectives from your side, Ravi?
Well, something of similar experiences of math, yes. Always go for a version or lesser two so that you know these versions are stable. And then one of the things that is very critical is to test them extensively in your user before you go for production in the user experience. So it's very critical for to create the test cases which are wholesome, that really covers all possible scenarios. Because in my personal example, there have been cases that we failed because the test cases were not wholesome. They did not cover the all possible scenarios. It not because of any other drawback. It's just because the test cases were not wholesome. So yeah, the idea is definitely to create test cases around all possible scenarios.
That's interesting take. I also heard that some investment banking, which is highly regulatory industry, are developing their own programming languages, their own programming interfaces and environments, which is quite difficult later to use the open source latest and greatest stuff. But obviously there are different approaches. Another interesting question, more about probably the infrastructure. Do you have any kind of advice when a business should consider distributed AI, distributed machine learning capabilities over the standard ones? What are the main drivers or criteria for this, as the different can impact the in-house hardware of the cloud services? Matt, would you like to take this one?
Yeah, I think I'm going to interpret it as distributed in the development process. So I think from a development perspective, you have to understand what your use case is, and I have seen issues with some distributed development efforts with to be able to make sure you can still ensure that explainability layer. Obviously, there is a compute gain that can occur, become much more efficient in the development process, but some of those results may be shifted slightly. You might have a slight different calculation because from a distributed approach versus a standard non-distributed approach in development. So that can affect your end predictability. So that little bit of a shift in the variances getting calculated could actually be affected by doing distributed. Now, simple calculations probably not going to be affected at all. From a deployment angle, if I were to look at this from that, I think distributed is your way to go. From once you have a set of score code to be applied, or a set of code that you want to put into production, it doesn't have to be a score. Scores are a lot of what my team works with, but you could have a process that's driven from a recommendation or something that is trying to create that in production. Distributed for that, if the process can be done in a distributed fashion, I highly recommend it. I think that's a great way for deployment to be as efficient and effective as possible. I think that's some of the gap, and I saw this on my team recently, where we're going from trying to test some distributed methods on our local machine, and then saying, how do we take that to production, and realizing we actually got no gain in production, even though we saw some gains on our local machine. So I think it really comes down to what you need for your specific use case or job you're trying to complete. I think distributed really makes the biggest part to see is really the efficiency and effective part is so much more productive with some of those methods if you can apply them with what you're trying to accomplish.
Thanks. Another question from the audience. Can you elaborate more on digital application of AI practices, given the current trend that almost every company has to go digital right now? And also the need to shorten the time from the concept to the implementation. Probably what do you think about that?
Well, definitely, yes. In today's current scenario, like most of the business are now planning to move digital. So that brings a lot of digital data to most of the companies. And there are multiple ways to actually trap this data into and turn into insights. A few ways could be to do a lot of sentiment analysis to understand, what your consumer or your client think about your organization, how they feel about your service. The other could be is to gain some customer experience data and understand, what needs to be improved in terms of processes. Because if you're new to this digital platform and you really want to improve and gain more customers quickly, and at the same time at the back end, if you really want to understand, what channel is the most profitable, and then if you have different platforms where your organic and inorganic sales is driven, then you might have to fit some of the attribution model to understand the best channel, and then put your budget on those channels. So these could be some of the practical use cases for digital-led analytics.
Thanks. And question for Matt from the audience. What is the next big thing in the AI with practical use cases for the business?
I think I mentioned earlier the continued automation of just everyday processes, and I think we think of the ones we already see some of those occurring in. But if you start looking at it, I mean, there's even opportunity to automate and change the way everyday operations occur in what we like, even the work that we do. So I think you're going to see, from a practical perspective, our work isn't necessarily considered the most practical, but when you start to realize the integration where people go to more of a digital landscape, like was mentioned previously, you're going to see a continual transition to just everyday things that we're used to seeing being AI driven. You're going to start to see AI integrating in a layer where it isn't necessarily clearly visible, but you are dealing with a level of AI. That's one thing with, I think, chatbots were a great example where some people probably think they were dealing with a machine at one point, or not a machine, dealing with a human being at one point, but in reality, probably those have always been a machine. And you're going to start seeing more of those things where you go, the aha moment, they can say, well, hold on, that's not a human being I'm working with. I think the more improvement you see with voice recognition, you'll likely see it take an adaptable form that people are used to seeing every day. I don't know if that's going to be a skin tone type of layer with eyes and mouths and other things like that to make people more comfortable with it. But I think any of those interactions, you're seeing it occur in everyday applications, from fast food to grocery to areas like that. I think you'll see a big transition into areas that were so against it for so many years because they aren't going to have a choice. They're going to realize that there's an efficiency gain, a cost-effective gain, from applying these approaches. Not just to make people more efficient, but to realize, hey, we can shift where we have headcount working and what they're working on and what they're doing. And I know people think they should fear the machine, but it really is try to be ready for the changes that are coming to be able to adapt and fit into some of the situations. So I think the next big thing, if I had to pick one next big thing, it would probably be, no, it's really tough. I'd say it have to be something around. So self-driving cars is almost already in process, but what's an area that doesn't have any application right now that could be turned upside down? It's really difficult. It's a really hard question, to be honest with you. The more I think about it on the fly, it's like there's, I mean, what about automated education? I mean, what if you could put AI and all these people learning from home, and you have, I know there's apps and tools and things like that, but what if you actually had a teacher that was completely AI based? You integrate chatbots with layers, and you have all your education turns into AI. I mean, it's really the same material over and over, right? There isn't that much different interpretation over time. I think back to from all the way from like my beginning of school in kindergarten all the way through master's programs, there isn't that much that needs a human interaction. You can replace a lot of that now. So, and that's a great opportunity to go make a better good, because then you can free education up. I know there's Khan Academy and some of those things out there, but this would be, what if you just had a completely interactive, and somebody could do it on their own pace, their own scale, and turn it on and off as they see fit. Complete your education, your master's degree by the time you're 15 years old. I mean, what stops somebody from doing something like that if they have the on-demand availability at all times? So
yeah, you could
Very
have like a
interesting.
personalized teacher.
yeah.
I think interesting field is also right now in the healthcare, because a lot of the use cases, especially around AI, are speeding up due to the COVID-19 situation. I also see, for example, a nice demo from a telemedicine company that during the conversation, the doctor during the conversation with the patient had immediately the information about the emotion that the patient has, and when the doctor was explaining something, then the pop-up says that the patient is confused, and then the doctor started to explain it in a more, let's say, clear way, and it was very, very interesting. Okay, maybe question now to Puravi. Do you feel that the data encryption will be the mainstream at some point of time to maintain data anonymity?
Well, it's already is a very key thing, because given the mass volume of data that we all are generating, and this new age, with a lot of GDPR, at least it's very strict within the Europe continent, and then there are already talks within the US continent and others, where we really need to create some kind of policy and regulation to safeguard consumers. So definitely data encryption is one of the side project that will go hand in hand with the AI. As AI moves strongly, the two key things which I see like coming up is cybersecurity and data protection. So definitely data encryption is one of the key areas which will see a lot of developments in near future.
Mm-hmm. And also very closely connected with the data encryption, another question about how to deal with private data, the one that the company does not want to share. And typically military require clearance in order to access the data. Should we require a dummy subset or sign a non-disclosure agreement? Matt, what's your take on this?
Yes, we actually have some recent experience with this. We have a lot of our clients that for example, in the insurance space, where they're very protective of their data, because their data is the big value of what they're trying to predict and accomplish. So we've been approaching it from a method of either obviously non-disclosure agreements are kind of those have to be taken care of. That's kind of just checking the box. But I think the other thing we're looking at is an anonymized data lake to be able to work with that data. So it's anonymized amongst all the different providers on some consistent structure and format that's going to be supplied. So you make sure you have a consortium of providers that end up anonymizing in a sense that they're able to still get value from each other without disclosing who is who and any of the personal identifiable information that are related to the layers. And part of it, you have to be able to mask anything identifiable or exclude anything identifiable, and also create some type of a standard ID process that still has some loop back to where it came from for someone to be able to identify their own data if they absolutely need to. I think with military and government data, it's a little bit different. Some of that is there's very top secret clearances and can only be housed and stored in certain places. So I think that's pretty difficult to work around. You probably have to work on their premise with their cloud, with their servers, with all their type of tools, I would think. But I do know they bring contractors in from outside all the time. So there are ways to work with it. You just may have difficulty ever getting that data to your local machine, for example. So
yeah. Okay, given that we are running out of time, thank you very much for the very interesting discussion. I hope our listeners enjoyed as much as I did. We didn't manage to answer all of the questions from the audience, but I guess we will get the list of the questions, and maybe we can follow up on those questions after the panel. So thank you very much again, Ravi and Matt. It was very nice to meet you and talk today about the practical AI aspects.
yeah,
Thank you,
thank you guys
Thomas.
very much. Yeah, nice meeting you both as well.
Thank you, guys.
Take care. Bye-bye.
Take care.
Bye.
Bye-bye.